Hello friends, today we discuss the quotient rule in differentiation. That means when y is a function as a quotient of two functions u and v, means y equal to u upon v, then how do we differentiate that type of function? For this friends, you need to remember this formula. If y equal to u upon v, where u is a function of x and v is also function of x, and u and v are in quotient form, then dy upon dx equal to v into derivative of u with respect to x minus u into derivative of v with respect to x upon v square. Just remember, in the denominator we take v square. So friends, using this formula you can solve this type of question. For example, let us take one case. Say y equals to x square plus 3 upon x minus 1. So we assume u equals to x square plus 3 and v equals to x minus 1. Friends, here I have used color codes so that it is better for you to understand when we substitute the values. Now, as you have done earlier also, when you take these two functions, take their respective derivatives also. So, when u is x square plus 3, we get the derivative du upon dx as 2x. Similarly, if v equals to x minus 1, then dv upon dx is 1. Now, we give the function u the yellow color, function v the purple color, and their derivatives. For the derivative of u, we used light green color, and for the derivative of v, we used light blue color. These colors will help you to differentiate easily. Now come to the formula. The formula was dy by dx equal to v into derivative of u with respect to x minus u into derivative of v with respect to x upon, in the denominator, v square. Now v function, as you see, purple color, this is x minus 1, so substitute the value. Again, du upon dx in light green color, it is 2x. Friends, always keep these values in brackets so that they don't mix up. Then minus, and again u function in yellow color, which is x square plus 3 in the brackets, and further derivative of v with respect to x is in light blue color, which is 1. Upon denominator we have v square, and the v function is x minus 1 in the purple color and its whole square, because in the formula it is not v but it is v square. Now friends, keep two things in mind. In the denominator we don't write v, we write v square. And secondly, sometimes you may forget to write the denominator v square. So always remember to write the denominator value also. Now solving these brackets, we can write 2x square minus 2x minus x square minus 3. Minus 3 because outside the bracket it was negative. Upon, in the denominator it is x minus 1 whole square. And then further solve, it is 2x square minus x square is x square minus 2x minus 3 upon x minus 1 whole square. So friends, this is how you solve this question. The only one thing you need to remember is formula and then you substitute the respective values. Again, take another example. Let y equals to x plus 5 upon x plus 1 whole cube. Now here the u function is u equals to x plus 5 and the denominator v function is x plus 1 whole cube. Now notice in the denominator it is the cube of the function. So you cannot drop that value 3. So v should be written as x plus 1 whole cube. Further, the steps are the same. Again we have used color coding so that it may be easy. Now when u is x plus 5, the derivative with respect to x is 1. And when v equals to x plus 1 whole cube, the derivative is dv upon dx. Now friends, you remember the chain rule? That was bring the power to the left, 3 is brought to left, write the base x plus 1, reduce the power by 1, that is 3 minus 1, into make the chain of derivative of the base, and the base was x plus 1. So it should be ddx of x plus 1. Now further solve this. You get 3 into x plus 1 raised to power 2 into, now derivative of x is 1 plus derivative of 1 is 0. So finally we get 3 into x plus 1 whole square. Now substitute these values in the formula. This is dy by dx equals to v. v was x plus 1 whole cube into derivative of u, that was 1, minus u was x plus 5 into derivative of v, that was 3 into x plus 1 whole square, upon x plus 1 whole cube raised to power 2. Now friends, here concentrate. In the denominator we write x plus 1 raised to power 3, which is function v, and in brackets the power is taken square because it is in the formula. So when you write, it becomes x plus 1 raised to power 6, 3 to the 6. Moreover, notice one thing, in the numerator the value x plus 1 raised to power 2 is common. So we take the common value, which is x plus 1 whole square, and in the brackets we are left with, in the first function we are left with x plus 1 in the brackets minus 3 into x plus 5, and in the denominator it is x plus 1 raised to power 6. So further solving, we get x plus 1 whole square into x plus 1 minus 3x minus 15. Now why minus 15? Because you remember outside it was minus, outside the bracket, so it becomes minus 15 upon x plus 1 raised to power 6. Now you cut 2 with 6, it becomes 4. So you are left with minus 2x minus 4 upon x plus 1 raised to power 4. So friends, you see, it is very easy to solve such questions. The only one thing you need to remember is the formula. And I hope you like this video. For further videos, please like, share and subscribe my channel. See you in the next videos. Thank you.